Hey there, I wanted to share with you a little thing I prototyped over the weekend. I Vite coded over the weekend using Cursor by basically just prompting what I wanted. I've had the idea to build a little game engine which works in the browser using React, Vite, because I know that very well and I can iterate very quickly, but also runs natively using an Electron wrapper. I used Three.js for rendering, and I basically started the project by just scaffolding the application using Cursor and then laying out the UI as you can see it in front of you right now, and then looking at each panel, for example, hierarchy, scene, inspector, and just prompting Cursor to fill it with life. Do this, do that. And again, I used my past experience using Unity and Unreal Engine in order to come up with a couple of ideas that I had for how a scene should be laid out and how users should be able to interact with such a system. It is very much inspired by Unity, no doubt about that. I know Unity the best, and it's my favorite and preferred game engine. But let's have a look what actually goes. So in front of us we have a default scene. It's empty except for a camera and a light. We can move around here, we can look around, and currently I don't have any nice looking models, gizmos for these technical entities in the scene. I just used dummy objects here. So for example here, this sphere represents the light and this cube represents the camera. And as you can see on the right hand side, whenever I select an entity, either in the scene view or in the hierarchy, I get the details on the right hand side in the inspector. Every entity has a transform component because this is a scene graph and all the entities here basically are laid out in the scene and form a hierarchy of dependent objects. And therefore this is always basically the local transform in relation to the parent. Whereas here in this specific case, camera and light are parent of the children. In this case, camera and light are children of the root object. Every entity, or rather every component, exposes a couple of properties. For example, the camera component has a field of view, near clipping plane, far clipping plane. The light has a type, and depending on the type, it exposes additional properties. Driven by Three.js because this is the rendering framework and it comes with a couple of default parameters we could use. Therefore, I just decided, okay, let's use these standard parameters. Don't get too exotic right now. Of course, we are also able to simply create our own entities in the scene. For example, if I right click, I can pick, for example, a mesh, and it's created in the scene. You can see it over here. By default, I'm using a primitive mesh type. We can switch between cube and sphere for now. And I can, of course, also work with the transform gizmos, move this around, rotate it, and scale it, of course. Now, we have worked in the scene view so far. Now let's switch over to the game view. The game view is basically what the camera sees. Right now I just pick the first camera I get and take this camera as the active one and render the scene into this game view. So you can see from the camera's perspective we look at this cube in the world. Also, you can see up here is a little play button, and in fact, I'm able to play this in editor, so to speak. So I take my current scene, basically duplicate it for runtime, and then just render it in the game view. But as you can see, nothing is happening because the game view or the game has no interactivity right now. Let's change that. What we can do is we can build our own component scripts. Component scripts add additional components next to the, or on top of the standard ones to decorate scene entities with it. It's a typical entity component system. Let's do a simple rotate.ts. Currently I have to provide the extensions myself. I'm going to change this, but now you can see what's going on here. I actually now have created this rotate component, and I can use it in order to affect any component where it's attached to. So let's try that. Let's imagine, for example, we have a private field called angle, which is of type number. We start with 0, and then we override one of the lifecycle methods of this component, which is called onUpdate. OnUpdate runs every frame. We pass in the delta time, the frame time basically, as a parameter, and we can work with that. So let's imagine, for example, we are just changing the angle that we have stored, just incremented by delta time. And then we apply this new angle to the cube's, or whatever entity it is attached to, rotation. Yeah, let's do, for example, this transform rotation from Euler angle. What is it? Euler angles? Euler angles? I don't know. From degrees. And use this dot angle for the Y rotation. And that should be it, right? So every tick, every frame, this method runs and rotates the entity it's attached to. Let's see. What we need to do is, in order to make this work and make this happen, we actually need to attach this script to the entity. I think I built drag and drop already. Let's try. Yeah, I have now dragged this rotate script onto my mesh scene entity, and you can see it appears over here. It's very simple right now. But let's quickly save what we have done here. I have not yet given a name, so let's use YouTube as a name. Here, actually, I get the .scene extension. Nice. And let's play and see what happens. So you can see the cube is, first of all, it's changing immediately because I change the scene rotation of the entity immediately with the first tick to 0, 0, 0. So it has snapped to the initial rotation, and now it starts accumulating the rotation on the Y. It's a bit slow though, so let's make it a bit faster in order to see the effect a little bit better. By the way, you can see while the game is running, the properties are automatically updated and reflected in the inspector. I can, in order to squeeze a bit more performance out of the system, disable that. And it should not be working. Let's ignore that. So in order to change the speed, what you typically do is you multiply this delta time with a certain speed factor. Yeah, so I could just go here and multiply by 10. However, I don't want to go back and forth and change the script every single time, and maybe I want to have two cubes rotating at different speeds, right? Both using the rotate script, but rotating at different speeds. Therefore, what we can do is we can use a expose decorator and expose a public property. We will call this, for example, speed. It's also a number, and we use, for example, 10 as a default value, and then we just do times speed instead, right? And okay, this should be updating automatically. I need to look into that, but what you see now, I have basically reselected the mesh, which has the rotate script attached, and now I have the speed as a property, and I can change it right here in the inspector without going back and forth and changing code, and also using different speeds for different components. Let's have a look. As you can see, it is now rotating much faster, and we can also duplicate this mesh, move this one a little bit to the side, and then use a different speed value for this one. Let's try what happens. Yeah, now you can see the back one is rotating at the old speed, the front one closer to the camera is rotating a little bit faster. I have not just built in these primitives so far, I also have basic FBX mesh support. For example, I have a couple of test objects here from my Synthi Studio asset collection. For example, a small building as an FBX file. And as you can see, when I click this here in the project view, basically from my asset library, I get a preview. And I can look at it and scroll and double check if everything is in order. And since oftentimes the modeling tools and the game engines use different scales, for example, unit 1 being 1 centimeter in the modeling tool and unit 1 being 1 meter in the game engine, we actually can configure the scale directly at the asset level. Therefore, when I import this mesh into the game engine, it is already scaled correctly. So basically 1 then means actually 1 meter, because I use meters here as well as a unit. I can drag and drop this object straight into my scene, and as you can see, it appears. It does not look great though, because it doesn't seem to have any material assigned right now. Let's also reduce intensity a little bit. Let's move this one up a little bit. What's going on? This mesh has no material assigned yet. Meshes or FBX files typically come with materials internally, but these materials basically need to adhere to the engine definitions of what a material actually is. Therefore, I decided to have an external material definition and then basically drag that onto my mesh. For example, here I created a Synthi material where the albedo texture map is already filled with this texture from Synthi Studios. Again, I can click on that in my project view. I get a preview of the file, and I can drag my created material, Synthi material, onto the corresponding slot. And as you can see, the object has changed. We now have a proper texture on it. It looks a little bit better. Obviously, you know, in a real life scenario, you would tweak the lighting, you would have a ground, and so on and so forth. What else? Currently we are using the skybox with a single color. You can see that here in the scene settings. I currently use solid color. We have other options, for example, using a gradient. Yeah, so you could play around with that. But what I prefer is actually using a cube map. So when we switch to cube map here, we need to provide a texture. So I'm going to drop this in here. And now you can see looks much nicer because now we have actually a sky in the background. Let's remove the ground plane here. Yeah, that's much better. By the way, I built this gizmo here in order to understand the current scene camera orientation, and also to quickly switch to a given specific perspective, basically, or basically look straight down, or from one given axis I'm clicking on to origin, which is often needed in order to get a good view of the asset or of the scene. And I can switch between perspective and orthographic projection. There is one issue. I don't know why, but when I switch to orthographic, I'm not seeing the skybox anymore. I need to investigate what's going on there. Probably, I don't know. All right, so this is first insight into what I've done so far. However, things would be quite boring without any interactivity. Therefore, I've also integrated a physics engine. I've never worked with that one before. I basically Googled for recent JavaScript or TypeScript-based physics engines, because the popular ones like Bullet, Amo.js, what's the other one? Razor? Not sure. They all are not actively maintained. And I found another one which is called Bounce. And it seems to be working fairly well. So we have the rendering with the scene graph on the one side, and we have the physics world with all the physics entities and corresponding colliders on the other hand. And they basically, every tick, more specifically every physics tick, these are basically synced. And that allows us to build things like collision checks, and I'm going to show this right here. We don't need that. So here I've built a simple scene. You can see there is this guy here. Let's quickly disable gizmos. This is my player character, constructed out of simple cubes and corresponding materials, but it also has two pivot points, left leg pivot and right leg pivot, and then under these pivot points again meshes. I use that in order to rotate the legs around this pivot point. You're going to see this in a second. And it also has a collider. In this case, the collider is basically represented again by another engine component, a physics component, giving us all the properties from Bounce. And in this case, since this is a player character controlled by the player, it's a kinematic body type. Yeah? The physics engine doesn't steer or control this physics entity, but the physics entity interacts with other entities in the scene. One of these other entities is this mesh. Up here, basically, there is a sphere. And again, this sphere has a physics component, and in this case it's a dynamic physics component, meaning it is supposed to interact with the world, to move around, to rotate, whatever. And it also has a script attached. I'm going to show this in a second. And also the player has a script attached. And this is a bit more complicated. But what I would like to highlight is that in a script, we not just expose primitive data types for editing in the editor. Actually, we also expose so-called scene entities, as well as assets, in order to reference other entities already existing in the scene and to make our lives easier. For example, here this player script is responsible for rotating the legs, but it needs to know which transform to rotate, and therefore I have exposed two variables, left leg pivot, right leg pivot, and I have assigned the corresponding scene entities here. So if I click here, for example, I can see it here highlighted over here, and I can actually switch it over. I can drag the left leg pivot in here if I wanted to. Would be wrong, but I could try. And let's have a look at this player script. You can see here these are the scene entities I exposed, as mentioned, and then I have some internal tracking. And then there is another thing. I have built a simple input wrapper where I can basically ask, hey, is currently any key pressed and stuff like that. And I use that in order to move the player character around. I can move it left and right. I can let it jump. Currently, I have a hard-coded ground level at 0, but I'm trying to extend this even further to actually, basically physically interact and act like a typical character controller. Let's have a look how this looks like, right? So I can move around by clicking left and right. I can jump by pushing up. And I can actually interact with this sphere. So my own capsule collider now collides with the sphere collider, and you can see actually here in my debug log, you can see some output from the coin script attached to this sphere, which I'm currently building. Whenever a collision is detected, I invoke another method called onCollisionEnter, and I output the name of the entity that has collided with the sphere. Actually, I want to detect whether the player is colliding, but I forgot when writing this last night that the physics object, the collider, is actually a child of my player. So instead of asking, am I colliding with player, I actually need to ask, am I colliding with collider? Or since name-based collision checks are a bad thing anyway, maybe introduce something like tags, as I know it from Unity. Let's see, I'm not sure about that. I guess that's it for a first overview insight into what I've built. It's been just 2 days. It's crazy, blows my mind what is possible. I know this is absolutely not going to scale because, as I mentioned, whenever the game starts, the scene is basically cloned, and all the persistence, we can actually look at that when we open the scene here in the inspector view. We get a little excerpt of the scene representation as JSON, and that's nice for debugging but terrible for scalability. in particular, given that even unchanged fields like a default rotation represented as a quaternion or a scale uniform, it doesn't need to be persisted, right? It's default and it's redundant here. So this is definitely not the best way to persist stuff. By the way, entities and their attached non-default scripts look like that. So there is a scripts block, and every entry references to a script file by ID, and the exposed properties of this script can be overridden using these overrides fields. For primitive types, this is straightforward. For scene entity references, for example, I use the corresponding ID of the entity generated in this specific scene. Finally, let's have a quick look at my project settings. I already have basically the scene management, so the project needs to know which scenes are actually supposed to be inside of the game, and sometimes you have scenes lying next to that just for testing purposes. And I also have what I call packaging. What this does is basically go through all these scenes mentioned here, look at all entities referenced from the scene, and then look at all entities referenced from these entities, and so on and so forth, and basically collect all the entities that we need inside of the project, and then zip that, basically a game package, in order to put it next to a standalone player. And I also have this already. I just created a separate Electron project, reused the source code that I already had, asked it to basically open a file called game.pack right now, load it, and then present the first scene as configured here. And that's it. It works. It's super easy. Again, it won't scale, but it's a super nice experiment and super fun to try. Yeah, and it's funny, like this. You get this stuff out of the box, just by asking Cursor, hey, give me a dark theme, give me a light theme, give me a theme switcher. It's crazy. But I think, I have more than 20 years of software development experience and game development experience, and I believe knowing what you're doing, knowing what you need to ask, knowing how to prompt and how to use the tools like multi-agent capabilities and stuff like that is just a superpower. It's unbelievable. Yeah, so that concludes my first, probably only update of my little game engine project. If you have any questions, please let me know. And happy coding.